Hello, my name is Jesse Ellington, and this is my presentation on the homopolar motor. Now, the homopolar motor is named that because the magnetic and electric fields do not switch during its operation, unlike most electric motors that pulse either their electric or magnetic field to increase their power and stability. Now, like all electric motors, this one is still driven by the Lorentz Force, which describes a force interaction between the electric field and the magnetic field, generating a force that operates at a right angle to the flow of the particles, the charged particles moving through the magnetic field. Now, that implies that you need to generate both these fields and they need to line up with each other. So, the setup that I have here looks like this. It's a rather simple setup, pieced from parts that I found or could acquire cheaply at a home store. So it's 2 aluminum rails, a stack of neodymium magnets that I had laying around, 24 batteries, 20 of them C's, 4 of them D batteries, a level table, and these are all things that are easy to acquire. I could generate a fair amount of electricity, and the materials were somewhat ideal, if not flawed in their own little ways. So the battery pack generates 36 volts and 200 milliamps. Now, the Lorentz force is actually mostly driven by current, and so stepping up the current would be more ideal, but driving up the voltage does accomplish a similar goal, if not as less efficiently. So this was my original idea for my movable object on my 2 rails. It's going to have 2 washers on either end of a stack of magnets. Now I think this didn't work for a main reason, is that it was too heavy. The washers added too much mass to the system and the force could not overcome its inertia very well. I took the washers off to try and decrease the mass, but the system still didn't really work, and I think this was because the electric field did not have as clear a flow path through the flat rails as they stood, so I turned them up on end. Now this allows me to take the electricity and pass it directly over the magnets, creating an electric field that lines up perfectly with the magnetic field as it creates current. This moves the particles through the magnetic field linearly, which then actually creates a right angle and a kind of a looping force actually as it moves down the field, making it move one way to the other. Now, this did not have an easy time starting from stop, so in most cases you'll see me tap it just very slightly at the beginning, and once it starts moving, the force is actually able to overcome some of the directions. Now, periodically it will stop for some reason, and then I'll have to restart it, and it works out. Now, you'll see it actually moving to the right a lot, and that is mostly the force of gravity. So, let's just see. So remember that the Lorentz force is being driven by the charged particle and the electric field directly. Now, without loops, this system is actually pretty inefficient. So, and you cannot apply loops to a homopolar motor to create more end turns. So, the force here is relatively minimum. So, little imperfections in the magnets, the imperfections in the rails create dead zones for me unable to move it. You can see as gravity pulls it right, and then I'm able to generate some force and push it back to the left. This is me just trying to get along a run to show you a video. Sometimes I could try and build momentum with this system, and a lot of times it didn't work. Periodically I could, but I never got a video of it actually working effectively. So, and that's just me trying to find the right place. There's some sweet spots on the rails and I had trouble finding them. And this last video is actually showing me what I could do if I got the wheels to work. Sparks! It was just kind of fun to play around in the dark. It would shoot up these sparks from the washers as I rolled it back and forth along the rails. But there you go. That's my project on Lorentz Force and the homopolar motor.